Hello everyone, today I'm going to be talking about how my research is making today's software safer. And I'd like to begin with the perhaps bold claim that most of today's software is actually unsafe. And I have some numbers to back this claim up. Recent studies have shown that over 2/3 of the bugs in popular software like Microsoft Windows, Apple Mac OS, and Mozilla Firefox are actually due to software safety issues. Software safety bugs are those which allow programs to access memory that they should not have access to. In the benign case, this just causes programs to crash. However, in the more malicious case, it can enable attackers to compromise the programs you're running to access your sensitive information and run arbitrary code on your machine. As a recent example, a few weeks ago, Mozilla actually discovered a critical vulnerability in Firefox that would enable attackers to run whatever code they wanted in your browser. Now, this issue of software safety has gotten so severe as of late, that this past February, the US government felt they need to publish a press report imploring developers to make software safer. This report actually called out one specific culprit for the lack of safety today, and that is the C programming language, denoted here in the blue hexagon. C is a 40+ years old language that developers continue to use today because it is very fast. C code is very performant. However, this speed comes at a cost. It is very easy to write unsafe code in C. To solve this problem, the Defense Advanced Research Projects Agency has initiated the TRACTOR program. Now, TRACTOR is an acronym. It stands for Translating All C to Rust, denoted here by the brown R on the bottom of the panel. Rust is a much more modern, safer programming language that developers would like to be able to translate to because it is about as fast as C code while still being much safer. Now, when you talk with those who are working on TRACTOR, like I have, there is an elephant in the room that they do not like to discuss, and that is that C programs do not just consist of C code. They consist of a mixture of both C and CPP code, denoted here by the orange hexagon. Now, I know C and CPP sound similar. There are two different languages, and their enmeshment together makes it difficult to translate C programs to Rust code that not only runs correctly, but that developers can still read and maintain and work on for the future. This is where my research comes in. For the past 4 years at UCF, I've been researching methods to translate CPP code to C code. Once we have pure C, then initiatives like TRACTOR can translate this to Rust code that not only runs correctly, but that developers can read and maintain and improve on for the future. Our preliminary results are very promising. I published a study on CPP code usage at Thesis, the top software engineering venue today. If you'd like to view the 10-minute long talk video on YouTube, you can scan the QR code here on the slide and watch it. My key takeaway was that 32% of all CPP code usage is actually directly easy to translate to C code. And I'm working with a team of undergraduates now to create an automatic CPP to C translation tool to capitalize on this number, translate C code to Rust, and make software today safer. But until then, that concludes my talk.